Okay, section 2 is about special right triangles, and actually what I'm showing you is a shortcut. As long as we have two different types of triangles, we have a shortcut that we can use in order to find the lengths of the sides of those triangles. And in fact, the nice part is they only have to give us one side, and we'll be able to figure out the rest of the triangle. One of the special triangles is a 45, 45, 90. If you think about that, these two angles are congruent, right? So that means if the base angles are congruent, that means we have the sides across from them are also congruent. Remember that? So we actually have an isosceles triangle here. So this is an isosceles right triangle. All right. If we have this triangle, we can easily figure out the lengths of each side if we're just given one side. And I would recommend here that you write this triangle down and keep it in a place where you can see it as you're doing your assignment, because it's going to speed things up quite a bit. All right, so what it's saying is the hypotenuse, the side opposite from the 90, is always going to be the square root of 2 times the length of the sides. All right, so if we are given this length, say this length is, I don't know, 3. That means this length is 3 because it's an isosceles triangle. All right, as long as those sides are 3, we automatically know real fast that this length is going to be 3 times the square root of 2. And you can do the Pythagorean theorem if you want, but that would take way longer than what I just did there, because we know it. Every single time, as long as we have a 45, 45, 90 triangle, it's going to be square root of 2 times the length of the sides. All right? That's no big deal. But we can also figure out if they give us the length of the hypotenuse. Maybe it's, maybe the length of the hypotenuse is 4 times the square root of 2. Well, if the length of the hypotenuse is 4 times the square root of 2, we know 4 times the square root of 2 equals n times the square root of 2. All right? We know that that equals n times the square root of 2. All right? And we can just, all we have to do is solve for n, and we have the lengths of these two sides. So just solve for n. So get n by itself, so we'll divide by the square root of 2. Divide by the square root of 2. That cancels out, so n equals 4. Okay, well, these side lengths are 4 then. That's how easy this makes it. It makes it real short. Okay? So on a 45, 40, the length of the hypotenuse is square root of 2 times the length of the leg. All right. So here's kind of an example that I just gave you earlier. Notice, the first thing you notice is we have a 45, 45, 90-degree triangle. All right. So it's going to be an isosceles right triangle. They want us to solve for x. They only gave us the length of the hypotenuse, but we know from our shortcut that this hypotenuse equals n times the square root of 2. So n times the square root of 2 equals 6 times the square root of 2. All right. Divide by the square root of 2 to get n by itself. Divide by the square root of 2. Cancels out. N equals 6. So we know x equals 6, and this side equals 6. They're both the same. So that's fairly easy, all right? And one part, maybe I didn't make it. Forget about this. Maybe this is x, all right? And maybe I didn't make it too clear. Maybe this is 2. So these side lengths, they're n, right? In our triangle that we drew, in our formula, they're n. So I have n squared root of 2, right? They're n. So if I'm just given these lengths, I can say n equals 2, because that's what that side length equals on our little drawing. Okay, so that should be easy enough. What about a 30, 60, 90? This is actually our second special right triangle. All right, in a 30, 60, 90, this one's a little bit different. All right, it's not an isosceles triangle, so our two legs can't be the same length because it's not an isosceles triangle. All right, so what we have here, and again, I would copy this down to make your assignment go along a lot faster, but what we have here is across from the smallest angle. So the 30 is going to be our shortest side. Now I know it doesn't look like that in this picture, but across from the smallest angle is going to be the shortest side. So that's the one that's just n. All right. 60 is in the middle, and that's going to be across from that. The side is going to be the second longest side, which is going to be n times the square root of 3. If you think about it, the square root of 3 is a little bigger than 1. So like this is like 1 times n, but it's less than 2. The square root of 3 is like 1.4 or 5 or something like that. I don't know, but it's 1 point something. So it's a little bigger than 1, but a little less than 2, and that's good because our opposite, our 90, is going to be 2n. All right, so and that should make sense because it should be bigger than the other two sides. All right, so maybe that helps you remember a little bit better. Again, I would write this down to just as you're first doing this now. It's probably the first time you've ever done this to help you make things go a little faster. Okay. So here we go. We have a 30, 60, 90, and now I know it's a 30, 60, 90. Well, we're given the right triangle sign. we're given 60 degrees. Well, 90 plus 60 is 150. 180 minus 150 is 30. All right. So we're given that that's 30. All right. They want us to find those other two sides, and they just gave us a hypotenuse. Well, we had in our drawing earlier that our hypotenuse is going to be 2n. Remember, our drawing is this. If this is 30, this is n. If this is 60, this is n times the square root of 3. And if this is 90, this is 2n. So what we can say is we can say 14 equals 2n because that's the hypotenuse. That's this part right here. All right? Well, and all we have to do is if we solve for n, we can just plug it in to each side. Pretty easy, right? So just solve for n. So divide by 2, get n by itself. So we get 14 equals, oh, sorry, just kidding. N equals 7. So as long as we know what n is, we can just plug it in. So we can plug it in right here, and we can plug it in right here. All right? So we know that x, which is the side across from the 30, is going to be n. So x equals 7. That's pretty easy. We just filled 7 in over here. All right? And then opposite the 60 is going to be n times the square root of 3. So we know n is 7. So 7 times the square root of 3. See how much shorter that made that? All right. I'm not sure if I have a... Oh, I do have another example for you. Okay, here you go. Okay. So again, we have a 30, 60, 90 triangle. All right. They gave us the side opposite the 30, which we know is n. And opposite the 60 is n times, wow, that's weird, n times the square root of 3. And then 2n for opposite the 90. Okay? So we have opposite the 30 is going to be 4. So we say 4 equals, what's opposite the 30 is going to be n. So n equals 4. And that's nice because all we have to do is we just have to plug that in here. So we're going to have 4 times the square root of 3 instead of n. And 2 times 4. So y is going to be 8 because that's 2 times 4. And x is going to be 4 times the square root of 3. That's it for my examples today. Here's your assignment. And hope this helps. If it doesn't, go ahead and watch it again. Ask a friend. And have a good day in class today.